the 15th of September, 1940. Flight Lieutenant James Edgar "Johnny" Johnson squeezed the trigger button on his Supermarine Spitfire's control column, and the world erupted in thunder. Four 20mm Hispano Mk II cannons roared to life, spitting shells at 600 rounds per minute toward the Messerschmitt Bf 109 that had made the fatal mistake of crossing his gun sight. The German pilot, Oberleutnant Franz Stigler, banked hard right, expecting the British weapons to seize and splutter as Luftwaffe intelligence had promised they would. They did not. Instead, explosive shells tore through his aircraft's wing root, and within 3 seconds, Stigler was fighting a losing battle with gravity over the chalky cliffs of Dover. The German High Command had built an entire tactical doctrine around a fundamental miscalculation. British cannon-armed fighters, they believed, were tigers without teeth. The Hispano-Suiza cannon, that Swiss-designed marvel of engineering that had been licensed to Britain in 1938, was supposed to be temperamental, prone to jamming, unreliable in the frozen altitudes where modern air combat occurred. Reichsmarshal Hermann Göring himself had reviewed intelligence reports suggesting that British 20mm installations failed at rates exceeding 30% during sustained combat. His fighter commanders planned accordingly, training pilots to press attacks against Spitfires and Hurricanes, knowing that after the first burst, the odds would swing decisively in German favor. They were catastrophically wrong. The Hispano Mk II cannon that entered frontline service in the summer of 1940 represented one of the most successful weapons adaptations of the Second World War, unlike the earlier Mark I, which had indeed suffered from reliability issues due to its wing-mounted installation and belt-feed mechanism. The Mark II featured critical modifications. British engineers at the Royal Small Arms Factory in Enfield and the Birmingham Small Arms Company had redesigned the feed system, strengthened the mounting brackets, and solved the harmonization problems that had plagued early installations. According to research compiled in the Journal of the Royal Aeronautical Society's 1946 edition, the Mark II achieved operational reliability rates exceeding 92%, a figure that would have horrified Luftwaffe planners had they known the truth. The German expectation of British cannon failure was not entirely unfounded paranoia. Early combat reports from the Battle of France had documented genuine problems. Squadron leader Brian Lane of No. 19. Squadron had filed reports in May 1940 describing multiple instances where his Spitfire's cannons fired a handful of rounds before stopping completely. The issue stemmed from the original 60-round drum magazines and the stress placed on feed mechanisms during high-G maneuvers. Pilots complained bitterly that they were going into combat with what amounted to single-shot weapons, devastating when they worked, useless when they jammed. The British engineers worked with desperate urgency through the summer of 1940. The threat of invasion loomed. Every technical advantage mattered. Teams worked around the clock at Enfield, testing feed systems, modifying extractors, redesigning ammunition links. By August, production Spitfire Mark IIs and Hurricane Mark IIs began receiving improved cannon installations that transformed them from temperamental experiments into deadly predators. German intelligence failed to detect this transformation. Luftwaffe reconnaissance photographs showed British fighters with wing bulges indicating cannon armament, and German analysts assumed these were the same unreliable weapons encountered over France. Interrogations of downed British pilots yielded outdated information, as most prisoners had been shot down weeks or months earlier before the Mark II improvements reached squadrons. The German assessment remained frozen in time, a fatal case of institutional inertia that would cost them dearly in the skies over Britain. The 19th of June, 1934. Mark Burkett stood in the testing facility of Hispano Suiza in Geneva, Switzerland, watching his creation fire its first live rounds. The HS.404 cannon represented 5 years of development, a 20mm automatic weapon designed specifically for aircraft installation. Burkett, a Spanish-born engineer who had made his fortune designing luxury automobiles and aircraft engines, had turned his considerable talents toward weaponry as Europe's political situation darkened. The weapon before him fired at a cyclic rate of 600 to 700 rounds per minute, using a gas-operated mechanism that was both elegant and brutally effective. Each 20mm shell weighed approximately 4.2 ounces and carried either high explosive or armor-piercing payloads capable of devastating damage to aircraft structures. The French Air Force immediately recognized the weapon's potential. France licensed the design in 1935, designating it the HS-404 for their Marans Alnier M.S.406 and Dewoitine D-520 fighters. The cannon's performance impressed foreign observers, particularly the British Air Ministry, which was growing increasingly concerned about the inadequacy of their rifle-caliber machine gun armament. Wing Commander Ralph Sorley, who served on the Air Fighting Committee, had been advocating for a heavier armament since 1935. His calculations suggested that future air combat would involve high-speed, fleeting engagements where only the most powerful weapons would achieve decisive results. Britain secured manufacturing rights to the Hispano Mk II cannon in 1938 through complex negotiations that involved both the Swiss parent company and French licensees. The Air Ministry designated the weapon the Hispano Mk I for British service. Initial plans called for installation in new fighter designs, particularly the Supermarine Spitfire and Hawker Hurricane, both of which were being developed with provisions for heavier armament than the standard 8.303-inch Browning machine guns. The translation from Swiss design to British production proved more challenging than anticipated. British manufacturing standards differed from continental practices. The original Hispano Mk II design used metric measurements throughout, requiring wholesale conversion to imperial standards for British factories. The Royal Small Arms Factory at Enfield took primary responsibility for production, working from French manufactured examples and Swiss technical drawings. Engineers discovered numerous small incompatibilities components that worked perfectly in Swiss test facilities, behaved differently when manufactured to British tolerances. The first operational trials occurred in the spring of 1939, when a single Spitfire prototype received an experimental cannon installation. Test pilot Geoffrey Quill flew the aircraft from the Supermarine facility at Eastleigh, reporting mixed results. The cannon fired successfully during ground tests, but when Quill attempted firing runs at altitude, he encountered feed problems. The 60-round drum magazines, mounted in the wing's outboard of the landing gear, struggled to feed smoothly during negative-G maneuvers. The drums themselves added significant weight to the outer wing sections, affecting the Spitfire's handling characteristics. Despite these challenges, the Air Ministry pressed forward with cannon development. War with Germany appeared increasingly inevitable. Intelligence reports indicated that German fighters were receiving heavier armament and armor protection. The standard British fighter armament of 8 rifle-caliber machine guns, while adequate for destroying unarmored bombers, seemed insufficient against hardened targets. Air Chief Marshal Hugh Dowding, commander of Fighter Command, approved limited production of cannon-armed fighters while development continued on improved installations. The outbreak of war in September 1939 accelerated British cannon development but also highlighted the weapon's deficiencies. No. 19 Squadron received the first operational Spitfire Mark Is with Hispano cannon in June 1940, just as the Battle of France reached its desperate conclusion. Squadron leader Brian Lane led his pilots into combat over Dunkirk, where they encountered both the devastating power and frustrating unreliability of their new armament. When the cannons worked, they were spectacular single hits destroyed German bombers that would have required sustained machine gun fire. But stoppages occurred with alarming frequency, leaving pilots flying combat missions with perhaps 1 or 2 functioning guns out of 4. The 23rd of August 1940. Joseph Smith sat at his drafting table in the Supermarine Design Office at Hursley Park, surrounded by field reports that painted a disturbing picture. As chief designer following Reginald Mitchell's death in 1937, Smith bore responsibility for making the Spitfire an effective weapon system. The Hispano cannon reports were unambiguous. Current installations were failing at unacceptable rates. Pilots were losing confidence. Some were requesting their aircraft be retrofitted with machine guns, abandoning the superior firepower of cannon for the reliability of rifle-caliber weapons. Smith had identified three primary failure modes. First, the drum magazines proved inadequate for combat conditions. The 60-round drums required complex spring mechanisms to feed ammunition reliably. These springs weakened over time, and the drums themselves were vulnerable to damage during rough landings or ground handling. Second, the wing mounting system subjected cannons to flexing and vibration that Swiss designers had never anticipated. The Hispano Mk II had been designed for rigid engine-mounted installations in French fighters. Adapting it for wing mounting in British fighters introduced structural dynamics that affected feed reliability. Third, the cannons themselves were sensitive to temperature variations at altitude, with lubricants freezing and mechanisms jamming in the -40°C temperatures common at 20,000 feet. British engineers approached these problems systematically. At Enfield, teams worked on improving the cannon's cold weather performance, experimenting with different lubricants and modifying tolerances to ensure reliable operation in extreme conditions. The Birmingham Small Arms Company, brought in to expand production capacity, contributed manufacturing expertise that improved component quality. Most critically, engineers redesigned the ammunition feed system entirely. The Mark II cannon replaced the troublesome drum magazines with belt feed mechanisms adapted from captured German weapons. German engineers had solved similar problems in their Mauser MG 151 cannons, which used disintegrating link belts rather than drums. British designers studied these systems and created their own version, compatible with British ammunition. The belt system eliminated the spring tension problems that plagued drums and allowed for larger ammunition capacities up to 120 rounds per gun in some installations. Wing mounting received equal attention. Supermarine engineers reinforced wing structures around cannon installations, adding stiffeners that reduced flexing during firing. They redesigned mounting brackets to isolate cannons from wing torsion and installed damping systems that absorbed vibration. Each modification underwent rigorous testing at the Aeroplane and Armament Experimental Establishment at Boscombe Down, where test pilots subjected weapons to punishing trials that simulated combat conditions. The improvement program proceeded with remarkable speed. Britain stood alone against Germany following France's surrender in June 1940. The Luftwaffe was preparing for an invasion that would require air superiority over the Channel. Fighter Command needed every advantage. Prime Minister Winston Churchill personally followed the cannon development program, receiving weekly briefings on progress. The pressure on engineers was immense, but the technical challenges were yielding to focused effort. By late August 1940, improved Mark II cannons began reaching frontline squadrons. Initial reports were cautiously optimistic. Squadron leader Douglas Bader, commanding No. 242 Squadron, reported significant improvement in reliability during combat sorties over southern England. His pilots were experiencing stoppage rates of less than 10%. A dramatic improvement over the 30 to 40% failures with Mark I installations. When the cannons worked, their effectiveness was devastating. German bombers that had withstood sustained machine gun fire were torn apart by brief cannon bursts. German intelligence struggled to understand what was happening. Luftwaffe bomber crews reported increasing casualties to British cannon fire, but German analysts assumed this reflected improved British tactics rather than technical improvements. The fundamental assumption that British cannons were unreliable remained unchanged in German planning documents through the autumn of 1940. This intelligence failure would prove costly as the air war intensified. The 15th of October, 1940, Oberleutnant Wilhelm Balthasar, one of the Luftwaffe's most experienced fighter pilots with 23 confirmed victories, climbed into his Messerschmitt Bf 109 Emil at an airfield near Calais. His mission briefing had been routine escort bombers attacking London's docks, engage British fighters as targets of opportunity, exploit the known unreliability of RAF cannon armament if engaged by Spitfires or Hurricanes equipped with 20mm weapons. Balthasar had survived numerous encounters with British fighters. He knew their capabilities intimately. He knew, or thought he knew, their weaknesses. At 17,000 feet over Maidstone, Balthasar spotted a formation of Spitfires climbing to intercept his bomber group. He selected a target, a single Spitfire slightly separated from its formation, and dove to attack. The Spitfire was a Mark II identifiable by its cannon-equipped wings, exactly the opponent German doctrine suggested he should engage aggressively. Balthasar positioned himself for a high-side attack, expecting the British pilot to fire a brief, ineffective burst before his weapons jammed, giving Balthasar time to close and finish the engagement with his reliable machine guns and cannon. The British pilot, Sergeant Roland Beament of No. 87 Squadron, had different plans. Beament had flown Spitfire Mark IIs with improved Hispano Mk II cannons for 3 weeks. He understood their capabilities. As Balthasar dove, Beament executed a climbing turn that brought his guns to bear, fired a 3-second burst, and watched his cannon shells tear through the Messerschmitt's engine cowling and cockpit. Balthasar never understood what had gone wrong. His aircraft broke apart at 16,000 feet, and he went down with it, becoming one of Germany's first significant pilot casualties in the Battle of Britain. German loss records from October and November 1940 show a disturbing pattern that Luftwaffe analysts struggled to explain. Fighter losses were increasing disproportionately compared to bomber losses, and an unusually high percentage of downed German fighters showed catastrophic structural damage consistent with cannon hits rather than machine gun fire. The expected British cannon failures were not materializing. Instead, RAF fighters were inflicting devastating damage with brief firing passes that gave German pilots no time to exploit supposed British weapon deficiencies. Fighter Command's tactical doctrine evolved to maximize the Hispano Mk II's advantages. Squadron commanders instructed pilots to aim carefully, fire short bursts, and break away immediately. The 20mm shells carried enough destructive power that brief engagements were sufficient to destroy or cripple German aircraft. This contrasted sharply with machine gun tactics, which typically required sustained fire to achieve decisive results. Cannon-armed Spitfires and Hurricanes became force multipliers, each aircraft capable of inflicting damage that would previously have required multiple machine gun fighters. The Hispano Mk II's reliability transformed from liability to advantage as autumn progressed. By November 1940, field reliability exceeded 90% in most squadrons, a figure that would have seemed impossible 6 months earlier. Pilots who had initially distrusted the weapons now requested cannon-armed aircraft preferentially. The psychological impact was significant. British pilots entered combat knowing their weapons would function, while German pilots operated under increasingly questionable tactical assumptions about British weakness. Statistical analysis compiled by Fighter Command in December 1940 revealed the Mark II's impact. Cannon-armed fighters achieved an average of 1.3 kills per combat sortie, compared to 0.8 kills for machine gun-armed aircraft. The difference stemmed partly from the cannon's destructive power, but also from the efficiency of brief engagement tactics the weapon enabled. Cannon-armed pilots spent less time exposed during attacks, reducing their own vulnerability while increasing their effectiveness. The German High Command received reports about British cannon effectiveness, but dismissed them as exaggerations by demoralized bomber crews. Reichsmarshal Gring insisted that British weapons remained fundamentally unreliable, citing outdated intelligence from the Battle of France. This institutional blindness would persist well into 1941, even as Luftwaffe loss rates to cannon fire continued climbing. The failure represented a broader German intelligence problem, an inability to adapt assessments based on new information, particularly when that information contradicted established doctrine. The 3rd of January, 1941. The Birmingham Small Arms Company factory in Birmingham operated at maximum capacity, producing Hispano Mk II cannons 24 hours daily. Production had increased from 50 units per month in August 1940 to over 300 units per month by year's end. The expansion reflected both improved manufacturing processes and desperate urgency. Fighter Command needed cannons faster than factories could produce them. Every new Spitfire and Hurricane required 4 cannons. Replacement weapons were needed for damaged or worn-out installations. The demand seemed inexhaustible. Manufacturing the Hispano Mk II required precision machining that challenged British industrial capacity. Each cannon contained hundreds of components machined to tolerances of thousandths of an inch. The barrel alone required specialized drilling and rifling equipment capable of maintaining consistent dimensions across its meter-long length. British factories had experience with rifle and machine gun production, but scaling up to cannon production demanded new tooling, new quality control procedures, and new training programs for machinists and inspectors. The Ministry of Aircraft Production, under Lord Beaverbrook's aggressive leadership, coordinated the expansion of cannon production across multiple facilities. Besides Birmingham Small Arms, factories in Nottingham, Manchester, and Glasgow received contracts for components or complete weapons. The Royal Ordnance Factories contributed ammunition production, manufacturing high-explosive and armor-piercing shells in quantities that would have seemed fantastical before the war. By early 1941, British industry was producing over 1 million 20mm rounds monthly, each shell hand-inspected before delivery to squadrons. Quality control became critical as production scaled. Early mass production suffered from inconsistent component quality that caused reliability problems in field units. Air Ministry inspectors implemented stringent acceptance testing, rejecting weapons that failed to meet specifications. The rejection rate reached 20% in some production batches, a painful but necessary sacrifice to maintain field reliability. Engineers traced quality problems to specific manufacturing issues: improper heat treatment, incorrect tolerances, inadequate surface finishing, and worked with factories to correct procedures. The industrial achievement extended beyond weapon production to support infrastructure. Cannon armament required specialized tools for installation, alignment, and maintenance. Fighter Command established armor training schools where ground crew learned to service the complex weapons. Squadrons received harmonization equipment that allowed precise bore sighting of cannons to ensure shells converged at desired combat ranges. Ammunition handling procedures were standardized, with detailed manuals specifying storage temperatures, handling precautions, and loading procedures. Combat experience drove continuous improvement. Squadrons reported field performance data that fed back into design modifications. When pilots complained about excessive barrel wear, metallurgists developed improved steel alloys that extended barrel life from 2,000 rounds to over 5,000 rounds. When Arctic operations in Norway revealed cold weather problems, engineers modified lubricants and seals. The Hispano Mk II of early 1941 was meaningfully superior to the weapon deployed 6 months earlier, despite retaining the same basic designation. The Royal Air Force's cannon-armed fighters expanded beyond defensive operations over Britain. By spring 1941, Fighter Command was conducting offensive sweeps over occupied France, deliberately provoking Luftwaffe responses to destroy German fighters. Squadron leader Robert Stanford Tuck led No. 257 Squadron on these rhubarb operations, using his Spitfire Mark II's cannons to devastating effect against German airfields and ground targets. The Hispano proved equally effective against ground targets. A single cannon-armed fighter could destroy parked aircraft, damage buildings, and suppress anti-aircraft positions. The cannon's success influenced aircraft design philosophy across British aviation. The Air Ministry demanded that all future fighter designs incorporate cannon armament from the start rather than as an afterthought. This requirement shaped the development of aircraft like the Hawker Typhoon and the de Havilland Mosquito, both designed around Hispano installations. The cannon had evolved from an experimental weapon system to the standard by which all fighter armament was judged. The 9th of June, 1941. Generalmajor Adolf Galland, recently appointed general of the fighter arm for the Luftwaffe, reviewed combat loss reports at his headquarters near Paris. The statistics disturbed him. German fighter losses on the Western Front had increased steadily since January, particularly during engagements with RAF Spitfires and Hurricanes. More troubling was the nature of the losses. A disproportionate number of German fighters were going down after brief engagements, showing catastrophic damage consistent with 20mm cannon hits. The pattern contradicted everything Luftwaffe intelligence had claimed about British cannon reliability. Galland ordered a comprehensive review of British fighter armament capabilities. His staff compiled reports from surviving pilots, analyzed wreckage of downed British aircraft, and interviewed ground personnel who had examined captured RAF fighters. The conclusion was unavoidable and embarrassing. British 20mm cannons were performing reliably and effectively. The weapons that were supposed to be temperamental and prone to jamming were instead functioning with remarkable consistency. German tactical doctrine, built on assumptions of British weakness, was fundamentally flawed. The intelligence failure represented a systemic problem within Luftwaffe command structure. Field reports indicating improved British cannon performance had been filtered and dismissed by intelligence officers invested in maintaining established assessments. Junior officers who suggested that British weapons were more reliable than believed found their reports questioned or ignored. The institutional culture discouraged bad news, particularly information that contradicted previous intelligence conclusions. By mid-1941, the gap between reality and German understanding was dangerously wide. Galland attempted to correct the misunderstanding through official channels. He briefed Hermann Göring directly, presenting evidence of British cannon effectiveness and requesting revisions to fighter tactics. Göring reacted dismissively, suggesting that Galland was making excuses for Luftwaffe failures. The Reichsmarschall insisted that British cannon problems persisted and that German pilots simply needed to be more aggressive. This response reflected Göring's growing detachment from operational reality. He preferred comforting fictions to uncomfortable truths. German fighter pilots on the Western Front learned the truth through bitter experience. By summer 1941, most experienced pilots understood that engaging cannon-armed Spitfires required caution rather than aggression. The Messerschmitt Bf 109's advantages in dive speed and high-altitude performance remained, but the tactical initiative had shifted. British fighters could inflict decisive damage with brief firing passes, while German fighters typically needed sustained engagements to achieve similar results with their mixed armament of machine guns and light cannon. The situation worsened for Germany as British cannon technology proliferated to other air forces. The Soviet Air Force began receiving Hurricane fighters equipped with Hispano cannons through the Lend-Lease program. American fighters, initially armed only with machine guns, started incorporating 20mm cannons into their designs. The Lockheed P-38 Lightning and later variants of the Republic P-47 Thunderbolt would carry Hispano-derived weapons. What had begun as a British innovation was becoming an Allied standard, giving every major Allied air force a significant firepower advantage. German attempts to develop equivalent weapons met with limited success. The Mauser MG-15 120 cannon performed adequately, but never achieved the reliability of the Hispano Mk II German ammunition. Quality remained inconsistent, with dud rates significantly higher than British experience. More fundamentally, German aircraft design philosophy had emphasized lightweight and agility over heavy armament, making it difficult to retrofit existing fighters with sufficient cannon firepower to match British installations. New German fighters like the Focke-Wulf FW-190 carried heavier armament but entered service slowly, in insufficient numbers to offset Allied advantages. By late 1941, the strategic implications were clear. German fighters had lost their qualitative edge in armament. British and Allied pilots entered combat with confidence in their weapons' reliability and destructive power. This psychological advantage, combined with increasing Allied numerical superiority, shifted the air war's momentum decisively. The Germans' early miscalculation about British cannon performance had cascaded into a broader failure to maintain technological parity in a critical weapons system. The 8th of May, 1945, as Germany surrendered and Europe celebrated peace, historians and military analysts began assessing the weapons and technologies that had shaped the war's outcome. The Hispano Mk II cannon featured prominently in these assessments. The weapon had entered service plagued by problems, dismissed by enemies as unreliable, yet had evolved into one of the war's most successful aircraft weapons. Its journey from troubled experiment to battle-proven standard offered lessons about engineering persistence, industrial adaptation, and the consequences of intelligence failures. The Hispano statistical record spoke definitively. British and Commonwealth air forces had fired millions of 20mm rounds in combat, destroying thousands of Axis aircraft. The cannon had armed Spitfires that defended Britain. Hurricanes that fought in North Africa, mosquitoes that struck Germany, and Beaufighters that hunted submarines. American fighters equipped with license-built versions of the Hispano carried the weapon across the Pacific. The original Swiss design, improved by British engineering and validated by combat experience, had become genuinely universal in Allied service. The weapon's reliability and service exceeded even optimistic predictions. Final reliability reports from Fighter Command showed stoppage rates below 5% for properly maintained weapons, a remarkable achievement for any automatic weapon, particularly one firing explosive ammunition at 600 rounds per minute. British armorer schools had trained thousands of ground crew in maintenance procedures that kept cannons functioning through brutal conditions. Arctic operations, tropical deployments, desert combat. The Hispano performed consistently across every environment. The German failure to recognize British cannon effectiveness represented one of the war's more consequential intelligence failures. Had Luftwaffe commanders understood the weapon's true capability in late 1940, German fighter tactics might have evolved differently. Instead, German pilots spent months operating under false assumptions that cost lives and aircraft. The institutional rigidity that prevented German intelligence from adapting to new information reflected broader problems within the Nazi command structure, where bad news was unwelcome and established doctrine was rarely questioned. Post-war interviews with German fighter pilots revealed the weapon's psychological impact. Veteran pilots like Johann Steinhoff and Gunther Rawol acknowledged that engaging cannon-armed British fighters required different tactics than fighting machine gun-armed opponents. The knowledge that even a brief burst from a Spitfire's cannons could prove fatal made defensive flying essential. This caution, though prudent, surrendered initiative to Allied pilots who could press attacks confidently. The Hispano's influence extended beyond World War II. The weapon remained in service, with air forces worldwide well into the 1960s. It armed jet fighters including the Hawker Hunter and de Havilland Vampire. Engineers continued refining the basic design, producing variants with higher rates of fire and improved ammunition. The fundamental engineering principles that made the Mark II successful gas operation, belt feed, robust construction became standard for aircraft cannon design globally. The weapon's development illustrated how engineering persistence could overcome initial failures. The Mark I's problems might have justified abandoning the entire program. Instead, British engineers approached failures systematically, identified root causes, and implemented solutions. This methodical problem-solving, conducted under wartime pressure with Britain's survival at stake, transformed an unreliable experimental weapon into a war-winning system. The transformation required months of effort by hundreds of engineers, machinists, and test pilots, but the investment paid strategic dividends. The story of the Hispano Mark II cannon ultimately transcended the weapon itself. It demonstrated how technological advantage in warfare depends not merely on having superior designs but on the industrial capacity to manufacture them reliably, the training to employ them effectively, and the intelligence to assess their impact accurately. Britain succeeded on all three counts. Germany, despite formidable engineering expertise, failed fundamentally in the intelligence dimension. That failure, multiplied across thousands of combat engagements from 1940 through 1945, cost Germany any chance of maintaining air superiority against Allied forces whose pilots flew with confidence that when they pressed their trigger buttons, devastation followed inevitably at 600 rounds per minute. The Germans expected British cannons to jam. They kept expecting it long after evidence made such expectations absurd. The Hispano Mark II, firing flawlessly, wrote a different story, one inscribed in the wreckage of German aircraft scattered across Europe's battlefields.